Welcome to our channel GIS Resources. Ever wondered how satellites measure vegetation health, urban growth, or water bodies? Scientists use NDVI, NDBI, and NDWI, but why do these indices always range from 1 to 1? Let's break it down. First, let's talk about NDVI, the Normalized Difference Vegetation Index. It helps us measure how healthy vegetation is using two key wavelengths, near-infrared or NIR and red light. Plants absorb red light for photosynthesis but reflect NIR. The more NIR reflected, the healthier the vegetation. NDVI is calculated as the difference of NIR and red divided by the sum of NIR and red. This formula produces values between 1 and 1. Why? Because we are dividing a difference NIR and red by a sum NIR and red, which ensures the result stays within this range. NDVI close to 1 signifies healthy vegetation because of high NIR reflectance and low red absorption. NDVI near 0 signifies bare soil or rock because of similar reflection in both bands. NDVI below 0 signifies water bodies because water absorbs both NIR and red light. Now, let's look at NDBI, the Normalized Difference Built-up Index. This helps identify urban areas using the shortwave infrared (SWIR) and near-infrared (NIR) band. NDBI is calculated as the difference of SWIR and NIR divided by sum of SWIR and NIR band. Why does NDBI also range from 1 to 1? Because the formula follows the same structure, a difference divided by a sum keeping the values normalized. NDBI close to 1 signifies highly built-up areas because SWIR is strongly reflected and NIR is weak. NDBI near 0 signifies mix of vegetation and urban areas. NDBI below 0 signifies water bodies or dense vegetation. This makes it easier to distinguish cities from natural landscapes. Lastly, NDWI, the Normalized Difference Water Index. This index is designed to detect water bodies using green and near-infrared (NIR) band. NDWI is calculated as difference of green and NIR band divided by the sum of green and NIR band. Water absorbs NIR and reflects green light, resulting in positive NDWI values. NDWI close to 1 signifies clear water bodies. NDWI near 0 signifies land surfaces with moisture. NDWI below 0 signifies dry land, built-up areas, or dense vegetation. And just like the others, this formula also keeps values between 1 and 1. Now, here's the big question. Why do all these indices stay within the range of 1 to 1? 1. Difference and sum method. Each index follows the same mathematical logic. Band 1 minus band 2 divided band 1 plus band 2. Since we are dividing a difference by a sum, the result is always between 1 and 1. 2. Normalization. This method makes comparisons across different regions and times easier. Whether we analyze a desert or a rainforest, the scale remains consistent. 3. Balanced scaling. If one band is much higher than the other, the index moves toward +1. If one band is much higher than the other, the index moves toward +1. If both bands are nearly equal, it stays near 0. And if one band is much lower, the index moves toward -1. This universal approach helps scientists monitor Earth's landscapes accurately. Now that you understand why these indices range from 1 to 1, you might wonder, why is the SWIR band so important in remote sensing? Check out our video on Why SWIR Band in Remote Sensing for more insights. Like and share this video with others interested in remote sensing and hit the subscribe and notification button to stay tuned for more exciting content.